Right. Let's start with irrational numbers. So irrational numbers, you spend this whole chapter actually of roots and powers, you spend a fair bit of time learning about in grade 9. And it's a big part of the No Calculator Diploma, PAT, and it is done a fair bit then. So a lot of what I'm saying in this section shouldn't be extremely surprising or very new, but it is important to review it and go through it. And maybe you were sleeping that chapter and missed it. So we've got it in here as well. One thing that I do want to point out for you though, when you did it in grade 9, you had to remember a lot of things, all those exponent rules and laws. This time in grade 10, you don't need to remember it. Your formula sheet, right here, your exponent laws. You don't need to remember it. It is right here for you, all of them. Some of them are new. I think this one and this one are fairly new. All of the other ones you should have looked at before, but you have all of them now. So at the very least, right, you do have the rules. You just need to know to look for the rules and then follow them appropriately. All right, so let's get back. We'll talk about irrational numbers quick, and then go into mixed and entire radicals and go from there. So irrational numbers. So this pictogram here, a sort of special Venn diagram, shows all of our numbers, the real numbers. And we've got our naturals, which are our counting, our whole numbers, which include 0, integers, rational numbers. And I guess, rational numbers is what you did in grade 9, a lot of rational numbers. This one here, we look a little bit more at our irrational numbers. And those are the numbers that cannot be written as a fraction. These are the numbers like pi and the square root of 2, where they do not repeat or end. Right? It doesn't repeat or end, it's just going to go on forever, just like pi does. Right? Pi is your classic example of an irrational number. Okay, so when an irrational number is written as a radical, the radical is the exact value. Then we can use our calculator to determine an approximate value. And sometimes I do want the approximate value. I want it rounded to the nearest tenth or 100th, but often I want the exact value now. All right, so these are some numbers. Some of them are rational, some are irrational, and we are going to use a number line to order these numbers from the least to greatest. So let's just make them all decimals. So the cubed root of 13. So in your calculator, we need to find the cubed root. So we're going to go second math. Oh, sorry, not second, just math. And down to number 4, cubed root of 13. So this is about 2.35133. Square root of 18, and it repeats forever. It is an irrational number. Square root of 18, let's find out that approximate value. That's about 4.2426, and so on. The square root of 9, well, we know that one is just 3. The fourth root, so we're going to go 4, math, and down to 5. Now this depends on your calculator if you need to put in the 4 first or not, and I'll show you this in another video. 27 is about 2.2795. Right, and last but not least, the cubed root of negative 5, which is negative 1.709975. All right, and I make my number line now. I'm going to go -2, -1, 0, 1, 2, 3, 4, 5. All right, and just place them approximately where they should be. Well, let's do to go smallest to largest. So my cubed root of -5 is going to be right about here. I need to write the radical. Don't write your decimal. That's not the exact value. Oh, I missed my negative sign there. -5. And now the fourth root of 27. 2.27, so about there. Fourth root of 27. The cubed root of 13 is pretty quick after it. And the cubed root of 13. The square root of 9 is exactly on 3. And the square root of 18, taking the lead, 0.2. The square root of 18. All right, so when we're looking at ordering our irrational numbers, it's really just button pressing. It's knowing your calculator and how to get some of the cubed and fourth or fifth roots showing up on your calculator properly. Okay, let's just keep going though. And talk about mixed and entire radicals. So mixed and entire radicals, a radical is something like a square root. It could also be a cubed root though. It could be any kind of root. And just like an exponent has a multiplication rule, there is also a multiplication rule for radicals. So if I am multiplying by, if I have the radical of a times b, that's the same as the radical of a times the radical of b. Right? And this can help us simplify them, because that is what we are trying to do. We are trying to make these radicals smaller. So let's look at 24. All right, so first we can read this use this property to simplify square roots and cube roots that are not perfect squares or cubes, but have factors that are. All right, so I want to look at 24 and find a factor of 24 that is a square root. Well, 24, I could divide that by 4. 4 is a square root. Right, so I'm looking for square roots, perfect squares. And I know that 4 is a perfect square. And 24 divided by 4 is 6. So I'm going to write 24 as 4 times 6. All right, 4 times 6 is 24. I'm not changing this number value. It's 24 still. And now I'm going to use this multiplication property up top. I'm going to split up the radical over the multiplication. So it's the square root of 4 times the square root of 6. Okay, well, the square root of 4 is just 2. So I can write that as 2 times the square root of 6. Or sort of most simply, just 2 root 6. And that would be the square root of 24 simplified. Now to check, we put it in our calculator. The square root of 24, I get 4.8989794856, blah, blah, blah. I check, I put in 2 times the square root of 6, and I get that exact same number. So these two values are the same. again, in this section, you have that power to check your calculator, and you should at least know if you're wrong, which is kind of nice. Okay, let's keep going. Let's look at 30. Again, it's the square root, so I want to find factors of 30 that are a perfect square. So let's just start with finding factors of 30. So I've got 1 and 30, of course. That's not a very exciting one. 2 and 15. 3 and 10. Now is 30 divided by 4? It is not. Is 30 divided by 5? Yep, we've got 5 and 6. And then that's it. Those are the factors of 30. Can I simplify that at all? Right, are any of these perfect squares? No. No, they're not. So 30 cannot be simplified. Right, so that's a bit of the trick in this section. It's simplify if possible. So sometimes it's not possible. So square root of 30 is as small as we can go. There are no perfect square factors of 30. Okay, so when we're dealing with cubed roots or fourth roots, I find it easier to prime factor and look for that cube or the 4 or whatever we're looking for, because we don't really know very much about cubes right now. We're probably not very familiar with it, and it's very hard to just identify a cubed root right off the bat. So let's prime factor and see what we get. So 144, I'm going to go with 2, and that will give me 72, which I can divide by 2 again. I'm preparing for a lot of 2's here, and that's okay. I can divide by 2 again. 18. I know 36 is a perfect square, but I'm looking for a cube, right? So I need to keep going. And I can divide by 2 again. I'll get 9. I divide by 3. 3, and remember I divide by 3 one more time, so I end up with 1. All right, and my prime factorization here is 2 to the 4 times 3 squared. So that's just prime factoring 144. We can make sure that we are right. Put that in your calculator, and yep, that is 144. Okay, so I want to sort of rearrange these numbers so I have a cubed, because then I can take that out. I can get rid of it. So my 2 to the 4, I'm pretty interested in that, because 3 is less than 4. So I can write 2 to the 4 as 2 to the 3 times 2 to the 1, and then times 3 squared. That's still going to give me 144. I've just ungrouped that 4 2's into just a group of 3 2's and whatever is left over. All right, so let's do this multiplication. I'm going to go the cubed root of 144 is equal to 2 cubed times 2 to the 1 times 3 squared. Okay, now again, I'm going to use this law up here, and I'm going to start breaking it down over the multiplication, but I'm only going to break it down once. This 2 cubed, the cubed root of 2 cubed is what I'm interested in. The rest I'm going to leave together, the cubed root of 2 times 3 squared. Okay, the cubed root of 2 cubed. Check your calculator if you don't believe me, but these cancel. It's an exponent law, and I'm left with just 2. So 2 times the cubed root, well, what's 2 times 3 squared? 18. So 2 cubed root 18 is going to be my answer here. So I'm combining some prime factorization from the beginning, grouping it so I have groups of whatever my index is here. And again, we can put this in our calculator and make sure that we are correct. Make sure you're finding the cubed root and not the squared root, because that is, of course, going to be different. Right, and yep, they are indeed the same number. I just checked in my calculator, and you should check in yours as well. Okay, same idea, fourth root of 48. Let's start with some prime factorization. I want to get groups of 4 because my index here is 4. All right, so I'm feeling pretty good about doing it with 2's because I know there's going to be a lot of 2's that divide into 48. 48 divided by 2 is 24. Divide that by 2 is 12. I can divide that by 2 and I get 6. I can divide by 2 one more time to get 3. Divide by 3 and 1. All right, and I'm left with 2 to the 4 times 3. All right, this is perfect. I've got my index of 4. So I have the 4th root of 2 to the 4 times 3. Again, I break it up over that multiplication symbol. So the 4th root of 2 to the 4 times the 4th root of 3. All right, don't lose that 4 index. It's on both of our radicals. 4th root of 2 to the 4, these cancel out, and I'm left with just 2 times the 4th root of 3, and just 2 4th root of 3 is the most simplified. There's an imaginary and invisible multiplication here, so I don't need to write it out. It's just implied multiplication. Right, and that is the basics of what we're doing here. A little bit of prime factorization coming back in as we group our prime factors so that we are getting what we need, whether that be groups of 2, 3, 4, whatever that index, that number outside of your radical is. All right, and we can do this in reverse to sort of unsimplify. So write a mixed radical as an entire radical. Okay, so this is the mixed radical right now. I've got just a regular number and a radical. Like a mixed fraction is a full number and a fraction. Mixed radical, full number and a radical. If I want it as an entire radical, I need to go backwards in this. So 4, I can write 4 as the square root of 4 squared times the square root of 3. All right, well, what's 4 squared? That's 16. So I have the square root of 16 times the square root of 3. And just like how I could break it apart over multiplication, I can combine it back together over this multiplication. So I've got the square root of just 16 times 3, which is the square root of, well, what's 16 times 3? 48. And again, we can check that in our calculator, and we should get the exact same number. The square root of 48, 6.9282, right? They're not going to end. It's going to be a funky number. It's an irrational number, but we should be getting the exact same irrational number. It's a good way to double check your work, and indeed we are. All right, let's finish off these examples. Now I've got a cubed root, so I need to take the cubed root of 3 to the cubed times that cubed root of 2. All right, well, 3 to the exponent of 3 is 27. So this is the cubed root of 27. You'll take another step here. Times the cubed root of 2. cubed root of 27 times 2. And the cubed root, 27 times 2, is 54. Now, as you start getting more familiar with this process, I'm okay if you start skipping some of these steps, showing them. But I do, at the very least, want to see this step here, where, sorry, not that one. This first step, this one here, where you are writing the number outside as the cubed root of 3 cubed, square root of, excuse me, square root of 4 squared, etc. You're showing that step where you're making it as the radical. That's a really important step, and I need to see that in your work. All right, this one here, 7 times the square root of 3. So it's the square root, so I'm still using the square root, and 7 squared times the square root of 3. So that's going to be the square root of 49 times 3. And 49 times 3, probably heading to your calculator, the square root of 147. Right. And our last example together, our index is 5. That's okay. It's the 5th root. I know we haven't done much with that, but we're getting there now. So it's the 5th root of 2 to the 5 times the 5th root of 3. All right, the 5th root, well, what's 2 to the 5? 2 to the exponent of 5 is 32 times the 5th root of 3. Means you got the 5th root of 32 times 3, bringing them back in together. And the 5th root, 32 times 3, is 96. And that will be our answer for this section. All right, and that's what we need to do. So that's going from an entire radical to a simplified mixed radical, and essentially expanding, going from a mixed radical into an entire radical. All right, practice for this, as in everything else in math, practice is key. So get to work now. You've got some practice questions, and let me know if you need any help with this, and I'd love to help you out.